This video, the goal is going to be learn how to convert numbers into scientific notation and learn how to convert them out of scientific notation into a regular number. And we're also going to use, as the second bullet shows, we're also going to be keying in on how to use significant figures in scientific notation as well. You know, there's a reason why we do this, and it actually makes a lot of sense. So let's just jump right into it because it's really cool. What do you do if you have a number that's really small, like the mass of a proton? This is chemistry, and we're kind of dealing with small things here, atoms, electrons, protons, neutrons, etc. The proton's mass is that crazy small number. Now, if I'm going to ask you what that number is, or ask you to say that number to someone, it's very difficult. Okay, it's very difficult to express that number. Or if I ask you to actually enter into your calculator, how would you do that? Most calculators can't handle that number. So we need a way to simplify that number, and the answer is scientific notation. So we're going to be using scientific notation today, to try to get a handle on how to express numbers in a different way to make it easier for us to express them. So my kind of definition of scientific method is nothing more than a scientific method. My definition for scientific notation is that it is nothing more than a method for restating measurements or numbers. That's all it is. It's just a way for us to restate measurements or numbers. And the key word here is it's going to simplify. It's going to allow us to simplify really big numbers and also really small numbers. That's the whole goal of scientific notation, to try to simplify and express our numbers or measures. And scientific notation works like this. It takes this very large number, this is like 12 gazillion, and we're going to convert that into a number that's actually usable and expressible. When I throw this big number out there, someone might say that's 12 bazillion. I have no idea. That number is too big for me to express. In scientific notation, it isn't. Scientific notation does nothing more than take this decimal point. This is like a fake decimal point right here. I'm going to move, and I'm going to move it in between these two numbers. So eventually, it's going to be like 1.2 something. And your goal is to really just count this. Count how many times you move the decimal point. All right, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13. I've moved my decimal point 13 times, so my answer in scientific notation takes that crazy large number and says it's 1.2534 times 10 to the power of 13th. That's my answer in scientific notation. It's much easier to say 1.254 times 10 to the 13th than it is trying to guess what that number is if you don't know what that number is. And you're going to notice here, one of the things, my original number did not have a decimal point over here, and I kind of made an imaginary one. Really what that means is that the number of sig figs I actually have, these numbers are sig figs. I had 5 of them to start out with. So I have 5 sig figs to start out with. I just want you to see, in my scientific notation answer, I have 5 sig figs as well. I find them again there. Just make sure your answer has as many sig figs as the original problem. That last example was a very big example of a big number. This is a very small number. A number that goes out way into the decimal places. And this is, once again, hard for someone's calculator to handle this, hard to express it. We're going to change that by using scientific notation. Scientific notation always takes a decimal point right here. In this case, it's going to move it between the first 2 whole numbers, those first 2 real numbers. And let's go back, let's just move it. All right, it goes 1, 2, 3, 4, 5, 6, 7. So I'm moving this decimal point 7 places. And my number is going to be 1.25340 times 10 to the, let's count that again. I moved 1, 2, 3, 4, 5, 6, 7. 10 to the, watch this, negative 7. Okay? I have a negative right there. That's cool. It's not a bad number. Negative simply means my number is small. This number is a decimal place right here. This is a decimal. This is a very small number. And so when my exponent is negative, it's when I deal with decimals. Okay? Not like a decimal like 10.1 is a decimal. No, not like that. But when I deal with a number like 0.001, where I have zeros that I start out with, that's a small number. Small numbers simply mean negative exponents. That's all it means, guys. Once again, you're going to notice my number of sig figs. And when I have a decimal, these zeros here are not significant, and so the sig figs I had were 1, 2, 3, 4, 5, 6, 7, and I have those same 7 sig figs right here. So in chemistry, it's important that you do pay attention to your sig figs as well. On a test or a quiz, you might see something like this. I might give you the number as expressed in red on the very top of the screen, and your job might be simply to try to express it in a multiple choice. Now, this is the problem we just did a second ago. And I do want you to see here, the first thing you really need to do is just say, hey, there's a decimal place. Anytime there's a decimal, I'm going to have a negative exponent. Negative exponent, let's take the positive exponent. Hey, this is positive 7. That's not good. We need a negative exponent. Negative exponent means small number. Lastly, the question is, do the sig figs match? I have 1, 2, 3, 4, 5, 6, 7. There's 7 sig figs. Well, this has 5 sig figs, and this has 7. So, yeah, this has the right exponent, but the wrong amount of sig figs. So, right here, on a multiple choice test, that's kind of where you would key in on. For all you math nerds out there, just to give a little shout out to all you math guys, you know, the parts of sig figs, the parts of scientific notation, rather, are going to be this. You have a decimal part. That's right there. That's what it's called, decimal part. And then you have your exponent part, which is nothing more than a power to 10. It can be either positive or negative. So a little shout out to my math guys out there. Okay, can we convert this to scientific notation? It's a number that's actually it's greater than 1, so therefore it's going to have a positive exponent. Remember, any positive exponent, like +3, this is +3, this is -3, -3. The negatives mean that the problem begins with a decimal point. So that's not this, and that's not this. So let's check this out here. I'm going to make a fake decimal. It doesn't exist. I'm just going to make it right here. I'm going to move it 1, 2, 3. So this is going to be times 10 to the third. That's what I'm going to be moving. My decimal point is now moved between the 4 and the 5. So I'm going to say 4.5 times 10 to the third. And the reason why I'm saying 4.5, which does match this one, is because there are 2 significant figures in this number. The ending zeros are not important when there's no decimal point. Only when there's a decimal point is they're important. So I have 1 sig fig, 2 sig figs, and this here has 2 sig figs too. So number 1 is the correct one. This has 4 sig figs, and that makes this not correct. How about this one, guys? It's actually the same number as the previous slide. Let's just go there. But in this case, I actually just added a decimal point. I'm just trying to drive this point home. First off, it's a number that's greater than 1. Because the number is greater than 1, I'm going to have a positive exponent as my answer. I'm removing the negative exponents, all right? So now if I was to guess, I really just have a good 50-50 chance. Let's get better than that. I'm moving my decimal point 1, 2, 3. So it's going to definitely be to the power of 3. 10 to the third, I've moved it 3 places. How about the sig figs? This has 2 sig figs, this is 4. I have a decimal now. Decimal means I don't count the beginning zeros. There are no beginning zeros to count. It's not like there's some here. So I'm going to count 1, 2, 3. There's 4 sig figs. And my answer here has 4 sig figs. That's the best choice for my answer here in chemistry class. Guys, why don't you press the pause button and try to express this in scientific notation. I'm going to express it in scientific notation for you, but press pause before I get to my answer, because I'm going to roll right into it here. 78,000 expressed into scientific notation is going to be 1, 2, 3, 4. I've moved it 4 places. And so it's going to be 7.8 times 10 to the 4th. Alright, there is no decimal point at the very end over here, so I don't need to include it or those zeros in my answer. How about this? Can you go out of scientific notation and go into a real number? In order to do so, I usually will just rewrite the problem first down below, and now I have to unwind out of scientific notation. This one of the things you're going to be responsible to do. This is a power of 3, so I need to move my decimal point 3 places, and I'm going to go either 1, 2, 3 to that spot, or 1, 2, 3. And I think the answer lies in this. You have to know that a positive exponent is a number that is greater than 1. Like 2, 3, 4, 100, 1,000. So positive exponent means a number greater than 1. So therefore, when I unwind this, I can either have 6020.0 as an answer if I moved it this way. And if I moved it this way, it would be 1, 2, 3. It would be 0.0060200. Those are your 2 choices, sample 1 or sample 2, depending upon how you move your decimal point. And because I know it's a positive exponent, that means a big number, a number greater than 1. This is my answer, and this is not. If it was -3, yes, that would have worked. All right, guys, here we go. Let's convert into a whole number from scientific notation. The first thing I tend to do is just rewrite the original, decimal part over here. I have a negative exponent. Negative exponent means a small number. So I need to make this a small number. And I do that by moving the decimal point 4 places. 1, 2, 3, 4. And my answer is going to be 0.000750. For those of you who said, maybe I want to move it this way, 7.50, and move it 4 places this way, 1, 2, 3, 4. Now we're talking about a number that is 75,000. It's a very large number. My negative exponent means a very small number. So I'm going to just remind us that that's right there. All right, guys, that's all I want to wrap up here. Scientific notation is it's a great tool, a great way for us to express very, very large or very small numbers in a simple way. All right, hope the lesson was good. There's a couple of other lessons on scientific notation that I have also. Find them, use them too, okay? All right, guys, be good.